So a quick summary of how do you know if a function is one-to-one, right? How do you know if a function is one-to-one? We showed that if f of a equals f of b, then you needed to know that a equaled b, right? That was doing it algebraically. Second way we looked. Look at the graph, and it must pass the what? So the graph passes the horizontal line test. And that last bit of green right here, what did we say about the graph? It's either always increasing or okay, we want to do f of g of x, which is f of cubed root x plus 1. Everywhere I see an x on my f function, I'm going to plug in cubed root of x plus 1. So I have cubed root of x plus 1 cubed minus 1. Cubed root cubed goes away. I'm left with x plus 1 minus 1, which is x. We're halfway there. Now I want to go show g of f of x. So I get g of x cubed minus 1, right? Everywhere I see an x in my g function, I'm going to plug in x cubed minus 1. So I get the cubed root of x cubed minus 1 and then plus 1. Minus 1 plus 1 cancels. Cubed root of x cubed is x. I showed f of g of x was equal to x. G of f is equal to x. So is g the inverse of f? Yes. Next example. Let f be x plus 6 all over 2. Let g be 2 times the quantity x minus 6. Is g the inverse of f? Two things. You need to go show f of g of x is equal to x, and g of f of x is equal to x. What is f of g? Well, it's f of, I'm going to write 2x minus 12. Is that okay? Kind of distribute that? All I did was distribute. Okay, what is f of 2x minus 12? Okay, here we go. Everywhere I see an x, I'm going to plug in 2x minus 12. So I have 2x minus 12 plus 6 all over 2. I don't like doing this, but I've run out of room, so I'm going to go across. It's very bad. I know. Actually, I'm going to do it this way. Okay, what is 2x minus 12 plus 6? Minus 12 plus 6 gives me minus 6 all over 2. If I factor out a 2 in the numerator, I get x minus 3. The 2's will now cancel. What's my answer? X minus 3. Do I even need to go find g of f of x? I don't even need to find it. Because what is f of g of x supposed to equal in order for it to be an inverse function? It's supposed to be equal to x, is it? No, it's equal to x minus 3. So I don't even have to find the other composition. Since this was not just x, I can stop and answer the question, is g an inverse of f? No. And why not? Because f of g of x was not equal to x. Not even a little bit. Okay, some special notation. Special notation is used for inverse functions. The inverse function of f is this. It's a superscript of a -1. You read that f inverse of x. That's how you read that. You don't say f to the -1. I don't know why they decided that that was the inverse function, but they just did. And so anytime you see that, you read it f inverse. Got it?